Hi there, how are you doing today? Namaste, good morning, afternoon, wherever you are. My name is Vishnu Dutt and I work as a network architect in Cisco. If you see, the first thing of this agenda is why we are doing this session, right? And believe me, if you understand why behind any technology, any concept, any session, it really helps you understand that concept session well, right? For example, if you want to understand computer networking, you should ask yourself, why basically I am going to read this? Why this technology or computer networking is important, right? Similarly, IP addressing, subnetting, if you want to understand it thoroughly, just start in terms of why behind that, right? And why we are doing this session, the number one thing is, actually, when I take interviews, when I see somebody who is joining Cisco, I at least want these concepts to be clear, right? And if these concepts are clear, believe me, guys, it is going to be very good for you when you go for interview for any networking domain or anything else, which wherever they are interested in networking, right? So whatever the concept I have, whatever I have written in the agenda, I literally look all these things when I interview for a people or for anybody, right? So if you concentrate only for next couple of hours or maybe next few hours, I guarantee you that these things are going to be with you for a longer period of time, right? Now maybe we can share these recordings also with you, right? If you want to go this session once again, but believe me, just give me your 2 or 2.5 hours and I'll make sure that all these information is going to be with you in very simplified manner. Okay. Having said that, let's discuss the first topic, computer networking basics. Okay. So here I have a board here. And I'm pretty sure that you guys must be reading about OSI model from your Tenenbaum book and so on. So many things, right? Let's make it simple. Let's simplify the OSI model, right? Let's discuss what actually we have in the industry, right? So most of the times I have heard from people that yes, we have tcp-ip model, we have OSI model, right? But where exactly these models or these layers are implemented, right? So if you consider your mobile device here, whatever I'm writing, I will be writing in this with the red pen, right? So if you consider this, where exactly this TCP/IP model is implemented, it is everywhere, right? Whatever the device is connected to the internet or whatever the device you use to communicate with others, the electronic device, this TCP/IP model is everywhere. If I say this TCP/IP model has these many layers, means application, transport, network, data link, physical, it means that all these layers are there, exactly there in your mobile phone, right? If I consider I'm talking to you over my laptop, right? I'm using my laptop for this session. It means that my laptop has this TCP/IP model implemented, right? So what exactly these layers are? Let's simplify them. Application, transport, network, data link, physical, whatever these are. So if I consider your mobile phone, this mobile phone is having all these layers implemented. And now what you do, you are going to Play Store and install WhatsApp application. Your friend, maybe I'm calling this friend as a mobile B. It has also he has also purchased one mobile phone and installed WhatsApp over it. Right now, what's going on? This mobile A wants to communicate to mobiles B, and they open an application which is WhatsApp, and they just type simply hi there. Right, very simple. Everybody does that, right? Everybody do that. So now what happens to this data? Computer understand everything in the form of ones and zeros. So right now, if you consider this application layer, whatever your WhatsApp, whatever you write on the WhatsApp is gone into this application layer, right? Application layer does something over it, right? For example, whatever your data comes in the form of one zeros, or let's say the data is high, right? It Two, it does some operation onto this data and that pass this information to transport layer, right? And there is a pretty logical reason behind why we have these layers implemented, different layers implemented. Why can't we have a single thing to do all these things? So there is a pretty logical reason, and I will be explaining to you, right? So actually at the transport layer, if you consider, then there is a well-known protocol which we know as TCP is running. And the job of the TCP is to initiate a session, to maintain a session so that we can talk over it. For example, if I call, right, if I made a phone call, so what happens exactly? There is a channel which forms behind the scene. Whenever I dial a number, there is a channel forms between the mobile A and mobile B, and this channel is like this. This is a predefined channel, right? When we do this, and all the communication is going to be over this channel, but we need to have some common rules to make this channel, right? And it happens in our daily communication also. When I say hello, I should see the hello from other side also, right? It shouldn't be like this. I'm saying hello after dialing a number, and the other person is saying just bye. It doesn't have any meaning, right? So everything is implemented. So first thing first, what happens when the data reaches to transport layer tries to reach to the second mobile phone, right? And they initiate a session, and there is a full theory behind it, right? That is why TCP is a huge protocol which deals with this session maintenance, right? And whatever the application you are running, it runs on a particular what we call in technical terms we call a port. If you don't understand it, that is fine. So we call this as a port number. So this WhatsApp application will be running on some port number. So basically your data reaches from application layer to transport layer. So the data is in the form of a continuous streams, like 101010, whatever. So whatever happened when you convert this high to this bits form, right? Transport layer responsibility is to chunk this data, right? Is to maintain some meaningful information out of it, because over this medium you cannot send a data which is packed into a specific format more than a particular size. For example, in Ethernet medium, we have only 1500 bytes of data which you can send at a particular time, right? So if this data is more than that, then it's a problem. So it is the responsibility of transport layer, whatever it is getting from the application layer, to make different chunks out of it, and we call these chunks at different segments, right? You don't need to remember all these things, but I'm just giving them a name. So this is one segment, this is one segment. And believe me, if you write, hi, how are you? Then there are more segments like this, okay? This is the only responsibility of transport layer, to initiate a session, right? And then everything is going over this session. And then basically whatever the data it is receiving, it is partitioning them into multiple chunks. Then what happens? It sends all this information to network layer, right? A network layer basically is responsible to send data to a particular network. For example, this guy is part of one network, maybe he's sitting in Delhi, and he is in network number B, say. And this guy is sitting in another network, which may be network number A, right? So these are the two networks, right? So it is the responsibility of this network layer to send these segments, which it is receiving from a transport layer, to send it to the network B, right? It is the only responsibility of network. So what it does is, whatever it is receiving, whatever the segment it is receiving from topmost layer, means transport layer, it is just putting one IP address, its own IP address and the destination IP address into this, and then it is done. So it is the responsibility of network layer to send this data from this network to this network. And if some things are not making sense to you now, that is perfectly fine. It happens. But believe me, when we end this session, when we talking about connecting two computers together, and when we go behind the scene, you will be getting everything. Do not worry about it if you don't get much thing out of this diagram. But believe me, right now, I'm just saying you have a mobile phone, you have WhatsApp application installed in it, right? And you write an hi, it is going to be appear in the right side of the network, which is network B. But exactly what happens, your mobile phone has different layers implemented, and believe me, it is TCP-IP, right? And then TCP-IP consists of these 5 layers. Your data reaches to application, then your data reaches to transport. Transport layer is responsible for making a session with the other device, and then it is also responsible to segment whatever data you are receiving from the application, right? This segment is reached to network, and network layer just put IP addresses at the front of this segment, and generally you call this information as header, whatever these guys are placing, right? Network layers places IP address, it means that it is placing the IP header, you can say, right? It is very good, right? So the responsibility of network layer is to send this data from this layer to this layer, but in not layer to this network. But believe me, in this network there must be many other mobile phones also, right? So I need to identify out of this mobile phones to which mobile phone I need to send this data. I need to make sure that this goes to mobile number B and not to any other, right? So it means that once I reach to network, once I reach this network, I need to identify that I don't want to give this data here, I don't want to give this data here, or even here. I just want to give this data to this mobile number B. And how we identify this? There is another address which we call as MAC address, which you find at the data link layer. So MAC address responsibility is to find out a particular device in a given network, right? What is the responsibility of network layer? The network layer responsibility is to just send this data from this network to this network. Now we need to identify at which device we need to send this data, right? And that is the responsibility of data link layer. So what happens? Whatever you receive, and by the way, at the network layer, we call this segment a packet. A transport layer, whatever we are receiving from the application and segmenting it, that's why we call it a segment. So segment is here, packet is here, and at the data link layer, we have MAC addresses, right? So that is why whatever I am receiving from the topmost layer, means top layer, which is the network layer, which is having all these things, right? What I will do, I will attach one more header or one more piece of information, which is the MAC address information, right? Once it is done, so why I'm attaching this MAC address information? Because I need to know what is the MAC address of this guy. If I know the MAC address of this guy, and there are some nitty-gritties behind it, and we will be discovering it. Do not worry about it, right? So I need to place this MAC address here, and then to identify a particular device here exactly when it reaches to this guy, to network B, and then data link layer, what it does, it sends this everything to the physical layer, and physical layer is just transferring everything over the wire. So your mobile network, mobile device is connected over wireless medium, but believe me, at the end of the day, it is connecting to internet. And in internet, we have multiple networking devices, and I'm pretty sure that you have heard about routers and switches. So that's why I have drawn some routers here, right? So actually, whatever you are sending at the physical layer, we have converted everything into the form of electrical signals, and your electrical signals are traversing over this medium, right? The medium can be different. If you talk about optical, then we are talking about light, right? And I'm pretty sure you engineers have heard about this total internal reflection, or basically the things which are related to optics, right? Where you can send your data in terms of light, right? With the light speed. So here we are talking about wireless medium, where exactly you can say that your information, whatever it was here, was traveling in terms of electrical signals, and then it exactly reaches to this router. And believe me, this router is also having this TCP-IP model implemented, right? It means that whatever you are sending to this router, it is able to understand from physical layer to data link layer to network layer. And by the way, when I say router works on layer 3, it doesn't mean that it only understands layer 3. It understands network or whatever is below it. It understands data link, it understands physical layer. So the packet reaches here, routers understand it, and on the basis of whatever the IP address in that packet, it forwards that packet to another router, that from another router to some other router in the internet, until it reaches to network B. Once it reaches to network B, it reaches to physical layer, and from physical layer, it reaches to data link layer. Data link layer say that it needs to go to a MAC address, which is this device MAC address. Suppose the MAC address is say x:x, right? So it will reach here. From MAC address, basically you will be seeing that what IP address it needs to go, and the IP address belongs to this device, and that is why this packet reaches here. From network layer, basically we are moving it toward the transport layer, which is able to understand in terms of this segments, right? And then this transport layer send everything towards this application, which is WhatsApp, and this WhatsApp application is running on particular port, and that is why you are sending it to the WhatsApp application. So again, I'm repeating, the data reaches, the first thing first, this guy sends a packet, it goes, it travels through all this layer. Once all the processing is done, it goes out, reaches to these routers, and this router is sending them to a destination network. And which layer is the responsibility to send it to the destination network? It was the responsibility of this network layer. Who is responsible to identify the design once it identify the device once it reaches to network? Is the responsibility of the data link layer to identify where exactly this device needs to go into this, right? So this is the overall picture, actually what is happening behind the scene. And if you can understand only 10-15% of this board, of this blackboard, whatever I am whatever I am explaining, right? It is more than good for me, because it is my responsibility to cover the remaining 85%. But believe me, if you are getting 10-15%, this is good till now. Okay, so what I was thinking is that it is almost impossible to unmute you all so that you can ask question. It is always good if you can write your questions to Pankaj, and then he can redirect me those questions. So feel free to write your question. I am taking a pause of 1 minute here, right? I'm just taking a pause of 1 minute. Just type your questions, and Pankaj, if you receive any question, please do ask, and I will be happy to answer before going to towards the next board.
Vishnu,
Yeah,
sorry to interrupt. We have a question here. It says, how can we communicate with wireless network which is below the physical layer?
So guys, one thing, it doesn't mean, right, that physical layer means some physical connectivity. Okay, the name is physical layer because actually that is where you are transmitting your bits into the network, into the physical medium. That medium could be wireless, that medium could be Ethernet cable, and that medium could be optical cable, right? It doesn't mean that it should be physical, right? For example, if you have a mobile phone, then and you are connected to your router, right? If you are sitting at your home, you have a router, you have a Wi-Fi router, right? The medium between you and your Wi-Fi router is wireless, right? And it is a physical medium. You're getting my point? You do not need a wire to connect your mobile to this wire. This is this is just a medium. Okay. Any other question, Pankaj?
No, that was the only question for now.
Okay, and thank you so much for the question, guys. Means if things are making not, if anything doesn't make sense, even if I say 2 + 2 is equal to 4, and that is even not making sense, just do ask. Otherwise, there is no point of having this session. Try to make it interactive. Whatever comes to your mind, just shoot your question, just write your questions to Pankaj, and I'll make sure that I'll cover them. Okay. So after second board, I will be taking a pause of maybe 5 to 10 minutes to just answer your questions. Okay.
Vishnu, sorry to interrupt again. There's another question of explanation. Can you explain the difference between MAC versus IP?
Yes, definitely. I will be, and you are asking a question which I am going to explain in other board. So do not worry. This is, and believe me, this is one of the most important question in networking, and most of the people don't know about it. So I am really thankful that you have asked this question, and believe me, we are going to cover this as soon as possible. Okay. Anything else?
No, I think we can move ahead, and yeah, after the second board, we can take more questions.
Yeah, sure. So by the way, how many people we have in this meeting right now?
At the moment, we had 391. We have 391.
Wow, this is good. So, okay. Now, so in the previous board, in the last board, when we were discussing about how two mobile phones communicate with each other, we have this internet, right? This box, and believe me, this internet is just interconnection of several networks. And if I talk about a particular network, it is combination, or you can say it is the combination of several devices, several networking devices. Those devices can be routers, switches, or firewall. Okay. So now we are going to discuss about these devices itself, and then we are going to discuss something about nitty-gritties of IP addressing, MAC address, and then we will be combining all these concepts to know how exactly a packet traverses from one computer to other computer. Okay. So now let's discuss about networking devices, right? I have mentioned only three. There are many, but believe me, if you know only these three, it is more than enough, right? So first thing first, when I say a switch, right? Almost all the 391 people who are sitting here, who are attending this meeting, knows that or read somewhere that switch is a layer 2 device. Router is a layer 3 device. And if you do not know about firewall, then I can say it is a layer 7 device. But what is the meaning of it? If I say layer 2, it means that it is capable enough of understanding the data link layer and physical layer. It means that it is safe to say that this switch has implemented, or this switch has contains data layer and physical layer. These two layers are implemented in the switch. Maybe we do not have any networking layer here. So TCP-IP model is there, but only last two layers are implemented. But believe me, in switches also, we have L3 switches, and basically switches also have many other variations, which are going to discuss by Lalit and after the session he will be providing me. But a switch, if you consider, generally it's a layer 2 device. It understands till layer 2. If I say it understands till layer 2, it means that if I have a packet generated by a network layer, at if I say network layer, so network layer generate a packet which we call IP packet, which is nothing but which is having a source IP address in it and destination IP address in it, right? Simple. But if I say that if this packet reaches to this switch, then it is safe to assume that this switch is not going to understand this, because switch doesn't understand IP address, because IP address are found in the network layer, right? So if this IP packet, and that's why I'm saying it's a packet, because the data transfer unit at layer 3 is packet, right? But if I send this packet to switch, switch is not going to understand it, and it will simply drop the packet. If it doesn't understand any information, it will simply drop it, right? So generally what happens, switch has interfaces. This is, say, if I name it, this say 0/1 0/0 interface. This is, say, 0/1 interface, right? So generally what happens, information comes into this switch like this. right? Switch sees that information, right? If it doesn't understand, it will drop it here. Very simple, right? But if it understands it, then basically on the basis of some things, some tables, it forwards that packet or that switch, right? So it is safe to say when this packet reaches here, switch is going to discard it because it doesn't understand this, right? But if I attach another piece of information like MAC addresses, because as I mentioned, right, at data link layer, and if I talk about especially Ethernet, there is another addressing scheme which we know as MAC address. And believe me, we are going to explain this concept. Why exactly we need two two addresses? Can't we work with only one, right? So IP address is there, we still need MAC address. Why? That was the question, right? So we will be explaining it. But for now, if I say switch is a layer 2 device, it is clear that it is not going to understand this IP packet unless I put some information at front of it, right? And what is that information? Who puts this information? This information is put by data link layer. And what is that information? That information is source MAC address and destination MAC address. It's as simple as that. If this packets or basically at layer 2, the data unit is frame. Okay, so I will be calling it as a frame. Previously, it was IP address. I made it frame by just putting source MAC address and destination MAC address. Believe me, when this information goes here, switch is happy that it understands that, okay, it can read this data link, right? It can read source MAC address and destination MAC address because it has these layer implemented. And on the basis of the destination MAC address, switch forwards the packet. It's as simple as that. Again, I am just drawing this switch here. Suppose this is a switch. I connect one computer here. I connect one computer here, right? This is its 0/1 interface. This is its 0/2 interface, right? And suppose this guy A is sending a frame towards this switch, right? And what is that frame? The frame source MAC address is going to be, suppose, A:(A), although it is 48-bit, but for simplicity, I am writing it A:(A). And the MAC address of B is B:(B), suppose, right? So this guy A is sending the information or the frame with A:(A), and the destination MAC address is B:(B). So the whole sole purpose is this guy wants to talk to this guy, and how the communication is happening, I'm just letting you know. So this frame is reaching to 0/1 interface here, right here, right? So switch is intelligent enough, and believe me, it maintains a table. Okay, it maintains a table. So it says that if a packet comes with again, my mistake, if a frame comes with a destination MAC address of B:(B), right, it needs to go out on the interface 0/2. Simple. So this frame reaches to switch. Switch with consult is its table, which says that if a frame has come with B:(B), it should go out with 0/2. So this packet will be going out here, and eventually it will be reaching here. It is interesting to know how switch build this table, and we are going to discuss it, believe me. But for now, you understand a switch is a switch. It doesn't understand IP address. It only understands MAC address, right? And it creates a table which guides the incoming frame so that it knows that where exactly we need to send this frame. Okay, getting my point? Guys, prepare your questions. Okay, I will be taking a pause after 5 to 10, means after this board of 5 minutes. Just type your questions and I will be really happy to answer them. Okay, now comes with respect to this router. I mentioned router is a layer 3 device, right? It means that it understands layer 2, it understands layer 3, it also understands layer 1, right? So if I send if I send him this information, right, where it has IP and where it has MAC. So I'm pretty sure you by the time you know that switch, this router is pretty good in understanding this MAC, or and then basically we have this information, right? Which we are getting from upper layers, like WhatsApp. Your hi message is here. So at IP layer, IP headers are attached, and or IP addresses are attached. At MAC layer, MAC addresses are attached, right? So when this information reach to, and similarly, basically the router is also having interfaces. This interface, suppose it is 0/1. This interface, suppose it is 0/2. Right? This is 0/1, this is 0/2. When this information reach at this port of this router, right? First of all, router will check that whether this information was for me, right? So this guy, this link is having the MAC address also, and suppose that MAC address is A:A, suppose, right? So the destination, suppose here is also A:A. So this router knows that yes, this frame is for me. And now I am smart enough to see the packet inside also. So it will remove this information, MAC addresses, and check what exactly inside the IP packet. The IP packet is going to be having source IP and destination IP, right? And it will check the destination IP, and accordingly it will take the action to forward, because this router again maintains a table which says that if a packet is coming with this IP address, say x.x.x.x, I need to send it to my interface, which is 0/2. So if I say router work on layer 3, it means that they understand the MAC address, and that is why they are going into deeper into understanding IP packet. And in IP packet, they see that the destination IP is x.x.x.x, right? So they checked their table and found that if they want to reach, if this packet wants to go to x.x.x, it is going to reach via 0/2, which is this interface. So this packet will be going like this. It's as simple as that, right? Third thing, and believe me, we are going little bit deeper in next board also, right? So if you are getting at approximately 20 to 25% of this board, that is more than enough for me. Okay, but try to understand. If you don't understand, just ask questions. Okay, if you're not getting it, again I'm repeating, 2 + 2 is equal to 4. It is like this, right? If you don't even get that, just please do ask, and I will be happy to answer. Then here we have this firewall, and I'm pretty sure that you guys have heard about firewalls also, right? So suppose if this guy here, computer A, wants to talk to computer B, but I do not want to create a network where A can talk to C, right? For example, A is an engineer, B is an engineer, right? C is the computer of an HR, right? This HR doesn't want that basically means your company policy says that A can talk to B, right? But this B and C should not talk to HR, right? In terms of certain application, maybe means that there shouldn't be any barrier talking to HR, but there are some applications in the enterprise where this A and B cannot access, but HR can access. So it means that you are creating access policies. You are saying this traffic can go, this traffic cannot go. So what you can do is you can place this firewall here, and you can create a rule, simple rule, that there is a traffic going on between A towards B, permitted, right? But if there is a traffic from A to C, just deny it. If there is a traffic from A to B, sorry, B to C, just deny it once again. And that is the role of firewall, to just introduce some of your security policies or access policies. Okay, 3 things, very simple. Switch works at layer 2. It means it understands MAC addresses and only MAC addresses, because IP comes at layer 3. right? So switch can decide on the basis of only MAC addresses where exactly it needs to send the packet. But a router can see the MAC address as well as IP. So it first checks whether this packet is for me, and it checks on the basis of what the MAC address of itself, right? Right now in this diagram, the MAC address of the router is A:A, and the MAC address of this frame, the destination MAC address of the frame is also A:A. So this guy understand that this frame is for me. Now I am free to just go inside into this packet to see source and destination IP addresses, right? It checks the destination IP addresses, and by the way, it maintains the table also, and that is why, and we call that a route table or routing table, right? Inside that routing table, it sees that, okay, this is the destination IP address, and if the destination IP address is x.x.x.x, I need to send it over 0/2, which is this guy, and it will send this packet out of. And then the third thing comes, which is your firewall, right? It is just only to control your traffic, although there are a lot more functionalities of firewall. But let's not go much into that, because here, believe me, the main thing which firewall is doing is controlling the access, managing your security policies, right? A should talk to B, but A should not talk to C, or B should not talk to C. Although there are mechanisms on routers or switch also to do this, but believe me, the firewall is the device which is doing all these things in a much more efficient way, right? So if we talk about networking devices, if you understand these three, it is really, really good for you guys. Switch, router, firewall. With that, I would like to stop for 2 or 3 more minutes to just take your questions. Pankaj, do we have any question?
Hi, Vishnu. I think let's give them a minute to come up with questions.
Yeah.
We
Come
have
on,
a
guys.
question. We have a question here. Can you please tell us more about routing table?
Definitely, I will be telling you in the next board. Do not worry, we will be creating the routing table for you. But for now, just try to understand. Router has a route table, how it is going to build that. Switch has a switch table or CAM table we call, how it is going to build that. Believe me, the last 2 boards I will be explaining only these things. But for now, just for simplicity's sake, just try to understand, just assume that anyhow this router has built this route table, and now it is taking the decision on the behalf of it, right? Oh, sorry, after consulting it. Similarly, switch has a CAM table, and switch takes its decision on after consulting that CAM table. How these tables are built, we are going to build in a step-by-step manner. Do not worry about it. Okay?
Yeah. We have one more question, Vishnu. It says, are all these networking devices unidirectional or bidirectional?
If those are unidirectional, then it is a problem, right? Means your WhatsApp is sending hi message to another device, but the other device cannot be able to send it, right? So it's a problem. So you can presume, right? It should be bidirectional. Otherwise, you would be able to send the data, but the other person cannot be, right? So it's a problem. So you can say all the devices are bidirectional, and you can see the arrows in that, right? In the switch, if you can see the arrows direction, it is going outwards, right? So it means that it is receiving and sending packets everywhere. Similarly, in the router also, it is receiving packet and sending everywhere else. Okay. Okay, the firewall doesn't have any arrows, so I'll make sure that basically it also sends. See, there is an arrow and there is an arrow. Don't worry about it. Okay.
Yep. And we have one more question. It says, from the point of view of a router, how does a router differentiate between MAC and IP address?
Oh, this is interesting. So, as I mentioned, that in router, all the layers are implemented, right? Okay. So, this, whatever the information comes, right, at layer 3 or layer 2. So, if I consider this router, all the layers are implemented here. Layer 2, layer 3, not all, but till layer 3, right? So, this information reaches to L1, right? And this will be forwarding this information to L2. right? And router, it means that router can understand L2, right? So this packet has a predefined, and that is why we call all of things as protocol. Protocol means predefined rule, right? So this router knows that starting some bits represent MAC address. After that, it represent IP address. So it checks inside even those starting bits, the starting 48 bits represent source MAC address. After that, they represent destination MAC address, right? It is structured. The packet is structured like this. So it is easy to read that, of course, in this complete frame, this is the information, which is the MAC address. Router can read it. If the destination MAC address belongs to its own MAC address, it means that the packet was for, the frame was for him, right? And then basically it eliminates it. It just discards this, right? Because now this information is not needed. Now the information needed is IP address. Then it consults its routing table, and then it takes decision on the basis of whatever there in routing table. Okay. But do not worry, means I just expect only if you get only 25% out of this board, that is more than sufficient for me, guys. Any other questions, Pankaj, we have?
Yeah, we have another very interesting question. It says if router can understand both MAC and IP address, what is the use of having a switch?
This is indeed very good question, and that is why basically I say the cost comes into picture, right? If router is understanding MAC as well as IP, it means that there is more code in this, right? It means it is more costly as compared to switch, right? But there are certain situations where you do not need a router at all, right? It means that you do not need to spend in router. You can purchase a switch, right? But I'm not saying that switch is not costly, right? Nowadays, and just wait for some time, Lalit will be here in explaining all those devices, and switch can be L3, means switch can also understand L3, right? But believe me, if you consider that switch is a L2 and this is a L3 with same number with the number of ports, then basically I can definitely say switch is comparatively cheaper and router is costly, right? And in your environment, if you do not need, if all the things works, for example, in case of your lab, whatever the lab you have in your college, right? If all these routers are just adjacent with each other, you can just connect them with a simple switch. You do not need a router. You just connect with switch and everything will work fine, right? You do not need a router. So you don't want to spend on router. Okay, so that is the main difference. But yes, by the end of the session, means those are really fantastic questions. I really like the audience here, and but believe me, when we are done with all the boards, 2 or 3 boards, you will get to know. But this is the main difference actually. Okay. Any other question, Pankaj?
Yep, we have 3 to 4 more questions. One of them is
wow, this is interesting then. Yeah, people are getting it. Means yeah.
It says, why do we have 0 in all the interfaces?
Oh, okay. This is just the naming convention. Means I can write this name. I can write this interface name as maybe Ram, or this one as Sita. Do not worry about these. These are just the naming convention. Don't worry.
Perfect. Next up, we have, does firewall restrict all the incoming data?
By default, see, there could be many rules which comes by default into the firewall, and generally in firewall, basically, if I consider 2 interfaces which is has, then basically this is the internal network, whatever you have. So suppose your lab, college lab, and then basically it is the external level where you connect to internet, right? So yes, from and we call this interfaces at, and now I'm not using 0/1. We call this interface as internal interface or inside interface to be precise, and this interface is outside interface, right? So the traffic which is coming from outside to inside is by default blocked, because you don't want that anybody can come in your lab and access the resources, right? But from inside to outside, it is permitted, right? But yes, you can change whatever you want to change once you understand firewall. But by default, it comes with this setting. You are right. It is blocking the incoming traffic from internet. Okay. I think it makes sense. Yeah.
Absolutely. Next up, we have how does the sender get the destination address?
This is interesting, and believe me, there is a protocol behind it. There is a theory behind it, which we are going to cover in the next board. Don't worry about it. Okay.
Wonderful. And next up, we have can you explain why we call these layers as L1, L2, and L3, which is again, I think, the naming convention.
Layer 1, layer 2, layer 3. So if L1, L2, L3, if I am saying, then if it is up to you, you can say physical data link network, right? But I believe it is just basically how many alphabets are used here, right? If you say physical or if you say L1, L1 is easy to say as compared to physical, right? Similarly, if I say data link or L2, L2 is it is always okay to say that a router is a network layer device, right? It is also okay to say that is router is a L3 device because this is your L5, this is your L4, this is your L3, this is your L2, and this is your L1, right? But if I say router is a L3 device, it means that it can work, it can understand L3, means IP addressing. It can also understand L2 as well as L1. Am I making any sense? Yeah.
Absolutely. Okay. Next up, we have we saw that switches and routers are hardware. Is firewall purely software, or we have a hardware for that as well?
I know that this is actually the assumption is even wrong here. If you are saying that these two devices are hardware, these two devices are also come into two forms. One is hardware, which you see in your college, right? Router and switch. There is a virtual form of them also, right? They are also come as a software. So if you already have a hardware, I can give you a router and you can install this thing on top of your hardware. Okay. Similarly, you can see the physical firewalls also is a box. Box is there, and believe me, Lalit is going to explain you. He's going to actually showcase you how these devices are looking, right? So software you cannot see, but believe me, all these things, which is router and firewall, comes in both the formats, right? They come in software form as well as they come in hardware form. Previously, Cisco was only selling, means I'm talking about 10, 15 years back, right? 10 years or 5 years back, everything was in terms of hardware. But now we are more towards software, right? Everything, whatever you are seeing here, available in software form. If you have your own hardware, you just install these devices and we are good to go. Okay.
Absolutely. There's one more question on why do we require switch along with router, I think, which was answered. And next up, which is, can you talk more about ARP?
Definitely, I am going to. Otherwise, the complete picture is not going to be formed. Believe me, see what we are doing here. We are trying to understand from overall perspective, and then we are trying to go deeper, right? There are two approaches to learn. First approach may be that you can understand the full picture and then go to specific details. The second approach is that you can understand the specific details and then you can combine. And believe me, in this, although I am fan of the second approach, understand the individual pieces and then combine, but believe me, I couldn't find a way so that you can understand everything. This is the simplistic approach, understand everything and then go into the nitty-gritties and then combine the solution again. So address resolution protocol, do not worry, we are going to discuss. And that we are going to discuss in the next board. Okay?
Perfect.
Anything else, Pankaj, we have?
Last two questions. We have, does firewall have some kind of table? Sorry. Does firewall have some kind of table?
Yes. So if I say that firewall is a layer 7 device, it means that it understands layer 2, it understands layer 3, it understands layer 4, right? And why I'm calling it it's a layer 7 device, because you guys are more comfortable with OSI. So if I say it is a layer 5 device, it makes sense, right? It understands all the layers. It means that it understands The layer 3, where IP addressing is there, where IP routing table is there. So it means that it has routing table, it has CAM table also, right? And it also has the layer 4 stuffs like port numbers and all, right? So believe me, yes, you are right. It understands everything.
Perfect. And then last question for now, which is the most efficient networking device, and what if the MAC and IP addresses are not proper? How will the device handle?
First of all, if MAC addresses and IP addresses are not proper or not understandable by the router, if you're done some spoofing in that packet, it is not going to forward that packet. It immediately drops. If it doesn't understand the packet or the frame, it is going to discard it, right? The second question is, which device is efficient? It depends on your need, right? Every device is efficient. Firewall, whatever it meant to do, it is doing it efficiently. Router, if believe me, at two interfaces of this router, we have different networks, right? So router interconnect to different networks. Switch is in your basically this kind of network where you have several devices, or where you have several laptops in close proximity, and then switch is connecting them. So every device is efficient. Maybe your question should be, in this switch we have different models, right? And whatever suits our need, I can pick and choose that. For example, this switch can comes with 48 ports, but if I don't have that many ports requirement, then I can go for only 8 port switches if I have only 4 or 5 or 6 devices, right? So in terms of efficiency, every device is efficient, right? It depends on your need, what you need to buy, a switch, a router, or a firewall. Okay?
Perfect. Just last minute, one more question. I think after that we can move ahead. If firewall can understand all the layer, is the data secured?
See, the question comes, basically in terms of security, the question comes that suppose I have this user, I have this user, and I have this user, right? Okay. If data is meant for this user, but this guy can also read the data, it means that data is breached and there is a security issue, right? But to maintain those rules, to maintain those policies, we need to put a device, right? We need to put a device here, which is, and of course, this device need to understand this packet. So whoever is managing this device, right? If your packets are, so if you are talking over internet, then basically it is the responsibilities of some of the responsibilities of application layer to secure your data. But believe me, don't go into that. But yes, this device firewall can understand the packets, right? And that is why basically your packet are going through it. So if you want to say that yes, this device can decrypt your packet, yes. So the administrator who is going to, and if this administrator is capable enough to decode all this packet, means using some tools, then obviously the administrator can have more easy access to your data, and he can see the data, the firewall administrator. And that is why basically it is basically we place firewall so that we can create the firewall policies. But yes, any administrator who is intelligent administrator can see the data.
Okay.
Okay.
Wonderful. Wonderful. That's all the questions we had for now. I think we can move ahead.
This is good, and thank you so much, guys, for thank you so much for your questions, and I am enjoying this session because you can understand it is really difficult over this online medium, because I do not know if you are if you are comfortable with whatever I'm teaching or not. So before going into the second part, where people are asking about address resolution protocol or some protocols, right? I would like to explain IP address, right? And believe me, and IP addressing and how you can create different networks out of a particular network, right? So this is good. This is good, guys. Good questions. So believe me, most of the guys, when it comes to understand IP addressing and subnetting, they just start spending time in those 10s and 10s. We are humans, right? we deal calculation in decimals, right? We are not meant to do calculation in the form of 1010. It is not the it doesn't mean that we cannot do that. We can do the calculation in bits, right, in binary, but we are from our childhood we are reading, or we are doing calculation in decimal. So it is always good to understand all these IP addresses in decimal number instead of 1010. And I have seen in the industry also that if I say somebody to divide this network into 5 parts, they just go and start thinking in terms of 1 bits or ones and zero, which is not the way to calculate, right? I am again not saying that you cannot calculate, you can, but believe me, if the calculation is going on in decimal number system, it is always good, right? So we will try to understand this IP address from the decimal number, means in which we are comfortable, from 0 to 9 counting, right? So if you know this, if you know only this part, right, the problem is solved. And we are engineers, right? We can memorize this thing, which is pretty easy. 2 to the power 0 is equal to 1. Then 2 to the power 7 is equal to 128. If I say 2 to the power 3, it means that it is equal to 8, right? And if I say if we talk about binary, right? If I talk about binary number system, then if I have only 2 states to change, right? Suppose I have only 1 bit, then it can have maximum 2 states, right? It can have only 0 and 1. It means that with 1 bit, I can represent 2 states. And I know people are very comfortable about it. If I have 2 bits, then it means that I can have 4 combination or 4 permutations out of it. What are those permutations? 0, 0, 0, 1, 1, 0, and 1, 1. And you must be thinking that this guy was asking that think everything in terms of decimal, and now he himself move into the zeros and one. Don't worry, I'm just saying that if you have 1 bit which can change only 2 states, it means that you can have 2 possible combinations out of it, right? With 2 bits, you can have 4 possible combinations, right? Or the permutations. And here 2 to the power 3, it means that if you have 3 bits, then you can have 8 permutations out of it. And what are those? You can easily calculate, right? And I believe everyone is so comfortable about it. And if we have 7 bits, then we can have 128 possibilities of those states, right? Now, just keep this thing in your mind, and let's start understanding IP address, right? So if you see that whatever I have written in this green color, it is an IP address 192.168.10.20. And believe me, it doesn't make any sense unless I write a number along with it. Suppose I write that number as /24. But the question is what this /24 is. And believe me, guys, these concepts are really, really important to understand when we are going to discuss how one computer in India talks to another computer in USA, right? Which are several networks apart, right? These are the concepts which are really, really important for you, right? So what I said, that whatever I written in green color, it doesn't make sense unless you write subnet mask along with it. But what extra information the subnet mask is adding? Let's see that. So, by the way, guys, this IP address is 32 bits, right? And 8 bits are here, 8 bits are here. So 8 bits are divided by this dot, right? The total number of bits are 32. It's very simple, right? And from 8 bits, it means that we can represent how many numbers or how many states? 256, right? Which are 0 to 255. And that is why here you will always see a decimal number which is in this range, 0 to 255. I think I'm making the sense, right? So IP address can be of 32 bits. It is separated by dots, and in behind in a particular dot, or if you can see this number, it is represented by this 8 bits. But we are not talking about those bits now, right? We are talking about the decimal number represented by them, right? So if I say that if I write this number along with this number, this this starts making some sense, right? What sense? If I say this is a 32-bit, this is a 32-bit long IP address, and if I say /24, it means that starting 24 bits are for denoting my network, and 8 bits are for my computers or host. What is the meaning of this information, right? I have said that this is 32-bit long. If I write /24, it has a more meaningful information, and I have taken out that meaningful information that starting 24 bits means network and last 8 bits means host. But what is the meaning of this, right? So suppose I have a group of computers, right? I have a group of computers which are, maybe so many computers are here. Maybe take an example of your lab, where computer lab, where we have almost 15, 16 or 18 computers, right? These are the computers, A, B, C, whatever, right? So if I say host, right, I mean these computers. If I say network, I mean the complete thing, which is this one, right? So if I say I have 8 bits for host, it means that how many hosts I can have in this network? 2 to the power 8, which is 256. Sorry, 256. So we can have 256 hosts. If I say, so basically this IP address represents a network in which 256 hosts are there. How can I define? Because I have written this /24 here. It means that 24 for networks, and how many total bits are there? 32. How many are remaining? Only 8. It means that 8 bits are for host. It means that that network contains 256 hosts, and I'm talking about the 20th host of that network. So this one is 1, 2, 3, 4, and say when I reaches here, this one is 20. So it means that what I'm saying is this is the 20th host of this network. Which network? Now, network is denoted by starting 24 bits. And what are those starting 24 bits? The starting 24 bits are 192.168.10.20. Sorry, extremely sorry, guys. .10, these are the starting 3 bits, right? But IP address should be fully, so we say first, we take first number as, so this is representing your network, right? Although this is the 0th host of this network, but we have denoted it with a network number. So as I mentioned, that starting 3 bits or starting 24 bits, which are till this point, represent your network. It means that this is the network number, and I am taken the starting 0th host, and I cannot give that IP address because that is reserved. So this number is here, right? This is representing this complete circle, complete network. And out of this network, the host number 50th or the host number 20th is the host which is having this IP address, right? So if I write, suppose if I write 192.168.10.70/24, if I don't write /24, it doesn't have meaning. But if I write 24, it means that I'm talking about the 70th host you can find in 192.168.10.0 network. This is as simple as that. Okay? Okay. If you don't understand this, this is the time to write down your question, right? To Pankaj, and Pankaj will make sure it will reaching out to me. But I have to explain one more thing in this board. So let me complete that and then I will come to your question. Till now, what we have discussed is if I write only IP address, it doesn't have any meaning. If I write an IP address along with, subnet mask along with the IP address, then it becomes a completely logical address, right? Whatever the number I write here, it means that this is the network number and the remaining bits represent the host bit. Okay, so suppose if I write a number, suppose say here 192.168.10.20 or say 25/25, right? Now this is confusing, right? Because now I am saying that starting 25th bits, represent network, and the remaining 7 bits, because total number of bits are 32. So the remaining 7 bits represent your host. And how many hosts can be in this network then? 2 to the power 7. It means only 120 hosts can be there, right? So if I take one address of the host from host to network side, it means that I am reducing from 256 128. If you don't get it, that is perfectly fine. Okay. But try to understand, if I don't write subnet mask, there is no meaning of that IP address, right? Let's go a little bit deeper now in understanding subnetting also. I'm not sure, but this laptop on which I am working right now is becoming pretty slow. Let me clean this board, guys. In the meantime, you can type your questions. Okay. 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 So now I discuss about this thing. So again, I am writing down this number once again in the same format. 192.168.10.20. So this was my number, /24, right? So as I mentioned that this is going to be having 256 hosts where .0 was reserved, right? And we have remaining 255 hosts, right? What I need to do now, suppose if I need to divide this network into 2 parts. Previously, we had 256 hosts. If I want to divide it into 2 parts, then how many hosts I should have? Obviously, so this network, what we are doing, the task is we are dividing this network into 2 subnetworks, and we are discussing subnetting, right? So if I am dividing this network into exactly 2 parts, it means that I am having 128 hosts in this network and I am having 128 hosts in this network. It's as simple as that. For 128 hosts, how many bits I needed? I need only 7 bits, because 2 to the power 7 is equal to 128, right? If 7 is the number of bits I used, right? 2 to the power 7 is equal to 128. Then how many bits I am going to use for my network? 25, right? So it means that if I presume it, that this network is going to be having 120 hosts, and those 120 hosts are from where to where? 192.168.10.0. This is going to be the first host. 10.1, it is going to be the second host, and similarly till we reach 10.127, because 0 to 127 is 128, right? And now, as I mentioned, the first IP address we choose for the network number. So first network is going to be 192.168.10.0 network /25. Why 25? You got to know it. And then 128 here, it means that the starting host till 127 are here. So we will start here from 192.168.10.20, 10.128 is going to be the first host, 129 is going to be the second host, 130 is going to be the third host, and similarly like this. And simply, this is going to be my network number, the first host address, right? So this way we can divide this network into two parts, and similarly we can divide this network into further two parts and whatever you want. And we call this complete process as subnetting. Very simple. And by the way, guys, there is a complete video which I have created and put on the bridge, which is my YouTube channel name. And Pankaj will be forwarding you those details. So all those details means there is going to be 18-20 minutes video where I have explained everything. So if things are not making sense from here on, just go and watch that video of subnetting on my channel. Okay. Now the time for questions. Yes, please. Pankaj, do we have any question?
Yes, Vishnu, we have quite a few questions.
Mm-hmm.
Let me get to them. Yes, if we take an example of Cisco's data center, how can we connect more than 256 end devices or hosts, or should we have to compromise on network bits?
There is no compromise thing like compromise, right? I have taken an example where I have put this /24, right? I can make, so for example, I need, and by the way, this is interesting and pretty good question. It means that you are getting 512. So I have taken an example where I talk about only 256 hosts. If I want to have 512 hosts, then definitely I need to work accordingly, right? I need to say that this is going to be /23 then, right? Or if I want to have, say, a network in which I can put 6,500 hosts, right? Then basically I can reduce this subnet mask from /24 to /16, and then last 16 bit 2 to the power 16 is going to give me that result. But believe me, if you create large network, right, that poses some challenges in some technical challenges in tcp-ip model, and that is why there is a concept of virtual LAN or network or subnet, right? But we do not want to go, but there is no compromise like this, right? If you want your network which has more than 6,500 hosts, you can have. You just need to reduce the network bits, right? And you just need to increase the host bit. But this means that you are getting the concept of subnetting or IP addressing. This is good. Yes, Pankaj, please, another question.
Another question, it's based on the same lines. What if we want to connect more than 255 devices to the same network?
We can. We just need to reduce the number of subnet mask. And that is why we have different classes of networks. For example, we have class A, right, where the subnet mask is only /8. Class B, where the subnet mask is class /16, right? It means that we are increasing the subnet mask, which means we are increasing the number of network bits and decreasing the host. So if you consider a IP address of class A, which I say 10.10.10.0, right, which writes /8, it means that there is only 8 bits for network and 2 to the power 24 bits, which is a huge number, right, for your hosts. It means that you can just create so many networks out of it to reach your range. Means maybe you need 256 hosts in a network or 512, whatever. You can divide this network into different subnetwork, and exactly this we do. This we do in designing a particular network. But pretty interesting question, very good, and I'm extremely delightful that I am making some sense in terms of IP addressing also.
Wonderful.
Yes,
yep. Next question is, can you talk more about dynamic and static IP addresses?
Dynamic and IP. So this is not the property of IP address. This is the property of device, whether it wants a dynamic IP address or static IP address. For example, if I consider your laptop on which right now you are working, you are attending this session, right? I am pretty sure that you haven't configured the IP address of this laptop, right? What do? You just connect, you just figure out your wireless network, you just connect to it. But what exactly happening behind the scene? You know, you have a router, you have a Wi-Fi router here, right? When you make an initial connection, this laptop asks for an IP address. And this is the responsibility of your device to revert back with an IP address and subnet mask along with the default gateway also, right? It sends all this information to your device. The process by which you are getting an IP address by not assigning but for asking is known as your dynamic, right? Dynamic assignment. Because you are not asking, you have not configured, you are asking it, and it is the responsibility of this guy who is providing you an IP address. It means that this guy is running some protocol, and that protocol is known as DHCP, Dynamic Host Configuration Protocol, through which you are taking an IP address into this device, right? But the other point is, suppose you just disable the DHCP in your router, the Wi-Fi router, which exactly is there in your house. If you stop this DHCP process, then you need to assign an IP address to this laptop. And where do you want to go to assign that IP address? You just go to your Ethernet NIC properties, NIC, which we call, right? Or the network interface card, because we also call Ethernet to this, right? You open the NIC, you open this TCP-IP properties of this NIC, and then you have the option there in the Windows or Mac machine to configure your own IP address manually. You need to define your IP and you need to define your mask also. Next question.
Next question. We have a very interesting question. It says, does increasing the number of hosts affect the efficiency of the network?
Could you please repeat once again?
Yeah. It says, when we increase the number of hosts, does it have an impact on the efficiency of the network?
Indeed, it happens. So if I talk about only one network where I have only 256 hosts and where I have only 512, this 256 node network was performing way better as compared to 512. What is the reason? This is an interesting thing, and this is related with this ARP, address resolution protocol flooding, right? In this network, there is less flooding. Flooding means if I have 512 hosts in this network, right? And there is a packet which needs to be processed by all the hosts, it means that we are wasting the resources here, right? But, and believe me, we are going to cover this, no worries.
Yep. And
yeah.
Next question.
But your question is correct. Yeah, go ahead.
Sorry to interrupt. We have quite a few questions, and next is why are we basically using subnetting?
Yes. So why are we basically needing a subnetting? So suppose this is an IP address range which is provided by which you have, right? And now you need to have one network for your say marketing team, one network if you're for engineering team, and one network is for some other team, maybe sales team, right? What if you can give the entire range to this? This is not making any sense at all, right? So suppose your marketing team has only 128 members. This has say 100 members. This is again has say 200 members. It means that whatever the range is assigned to you, you need to carve out a specific subnet out of it. And then you can create this network, and this network. Once you create these networks, now, basically, if you have created these networks, then basically you can have a firewall or a device which can control the communication between these two networks, who should talk to whom, right? So we segment the network, our complete network, into multiple business requirement, whatever the business requirements we have, so that we can put security policies. Okay, but subnetting is important because you need to, if you have a bigger IP address range, you cannot give all the IP address to a particular department. You need to subnet it, right? So this is the main reason. Yes, Pankaj.
Okay. Next is what is the difference between public and private IP?
Public and private IP. Yeah, there is a difference, but if I take that, it is going to take 10 more minutes. And I could see that we have. So in simple terms, if you have a public IP, you can talk to internet. If you have private IP, you cannot talk to internet, right? Private IPs are not routable over internet, right? But you can say whatever the example I have written here is the private IP address range. So there are some range defined by these guys, which comes across this private address range, right? These are not routable over internet, but it doesn't mean that you cannot talk to internet. And if you are talking with this private address range to the internet, then there must be somebody who is translating these IP addresses to public IP address. For example, if I take, okay, this is the important question to explain. So suppose you have a router here, right? You have a router. This is your Wi-Fi router, and you have one laptop here. If you do a IP config, if you are on Windows, or IF config, if you are on a Mac laptop, you will be seeing an IP address in this range, 192.168.something, right? And believe me, this IP address range is the private IP address range, right? And if I say that you cannot talk to internet if you have this range, then you can straight away say that this guy is a liar, right? Because right now I am attending his conference, I am attending his session, and I'm able to access the internet, right? It means that there must be somebody who is translating this IP address into an IP address which is routable over internet, and that is exactly what happens. So you go to internet and you say, I need a internet connection, right? Your service provider, maybe Airtel or somebody else, is giving you that internet connection, and exactly here you will be receiving a public IP address. Believe me, you just go and check your router, it will be a public IP address range there, IP address there. So what's happening? Your packet comes with this private address. This guy convert the destination, source IP address into the public IP address and then send. And we call this process as network address translation. Very important topic, very interesting topic also. Maybe you will be learning in upcoming sessions. Okay.
Perfect. There are a couple of questions which are on similar lines. I'll just club them. It's on can two devices and two different networks.
Yeah, but before that, Pankaj, means if the session, because I still have more boards, and
Correct.
most of the guys' question will be covering up. We will be covering them up there. So if I take
Wonderful.
15 more minutes from 4 to 4:15, is that fine?
That should be fine. We will have Lalit coming in, so we need to inform him.
Yeah, we can inform him. So because I really want, because people are really shown interest in this, so I want to cover those boards. Yes, please do ask question, but the
Yeah.
taking question is also as important as
We
covering.
can do one thing. If there is anything that misses out, if there is already on the YouTube channel, we can share the link and students can refer to that.
Yeah. Then basically I can explain the next board, which is carrying the load, and then the next board, there is a complete video on those two next board also. But I would really like to take one board where I can explain ARP, because there is a lot of questions around that, and then we can leave the last board. Okay.
Sure.
Yeah, go ahead with the
So
question.
I'll just try to club all the questions that are same. One of them is, can two devices in two different network have the same IP address? And the other is, if we have IP address, then what is use of MAC address or vice versa?
We are going to discuss this MAC address and IP address thing. But the second question was again interesting, that if we have two different networks, can we have same IP address? No, we cannot have. You can argue with me that my friend who is sitting in his home, he is also using 192.168 range, and we both can have the same IP address, but we can still communicating. But believe me, as I mentioned, that there is a device who is translating your address when you go out, right? No two IP address on internet, in terms of public IP address, no two addresses on internet can have same public IP address. Otherwise, there is a conflict and no communication can happen. Okay. So if you say that your friend is also using the same IP address, believe me, his router is again converting this IP address into a public IP address, whatever is given by its service provider, and this IP address of his router and your friend router IP address is totally different, right? There cannot be that these two IP addresses could be same. Okay, if these are public IP address.
Perfect. One more is why subnet mask is always 255.255.255.0 in computers.
No, it is not the case. It is not the case. If I write /24, and that is why I was not going into 255 thing, right? So I written that if it is /24, then it means that the starting, if I say 24, it says that starting 24 bits are 1, which represent network, and all remaining are zeros, which represent host, right? So if you can say all 8 bits are 1, right? It means that these are your, how many these are? 4, 5, 6, 7, 8. If you sum them up, means I have summed them up right here. 2 to the power 0, 1, 2, 3, 4. If you sum them up, then it is going to be a number which is 255. And again the 8 bits 255, again the 8 bits 255. And believe me, if you write 255.255.255.0, or if you write /24, both are the same thing. But as I mentioned, the subnet mask could be /24, sorry, 25. The subnet mask could be /20 /16. It means that it is going to be 255.255.0.0 in this case. Okay.
Perfect. And there are two.
But
There
it
are
is not the
questions.
case that it is always /24 or 255.255.255.0. Okay. Yeah.
Perfect. There are two more on dynamic addressing. Does the one of them is, does the IP address change on a real time in case of dynamic? And can you please speak more about a magic cookie in DHCP?
Magic cookie in DSCP. I really, that there is going to be slightly, we will be deviating from the topic if I do that. But
Mhm.
yes, just note down my email ID and please, or basically we can talk directly, right? But there are a lot of people, I really do not want to deviate from the main topic here. And regarding your second question, what was the second question?
Does
Pankaj?
the IP change real time in the dynamic scenario?
Yeah, so basically, when you when you switch on your laptop, it doesn't have any IP address. It asks for the IP address from your router, and it will straight away give it an IP address, right? But it assign it that IP address for 24 hours, right? And basically after 12 hours you just need to renew it that I am still on the network, I want this IP address. So there is a whole lot theory behind the DSCP, but believe me, if you know till this point that yes, there is a DSCP server which is giving you an IP address when you switch on your laptop, you are good to go.
Perfect. We have some questions on subnetting. I think Vishnu, for that, can we attach the YouTube link of subnetting video, and we will.
Definitely. So I believe you have attached my bridge channel, right?
Yep.
The name of my bridge channel.
Yep.
So I think the guys are here are smart enough. They that channel has several playlists, and one of the playlists say routing and switching, where you can find the very first video on subnetting. And basically there is an interview preparation series also there, right, where I
Right.
mentioned all these 15 16 questions. Believe me, if you know this much theory behind it, so those questions are not just like if you know the true false question that if you prepare them you can crack any interview. For every question there is a theory behind which you need approximately 2 to 3 hours to understand, and believe me, this 2 hour session is going to be important for you in understanding all those questions. Okay.
Perfect. So, yeah. So I'll be sharing the PPT which has the link, and I'll also make sure I'll create a slide which has all the resources to exact video link. You can leave your question in the comments, and Vishnu will be able to answer. Also, I'll be sharing his LinkedIn link as well, so you can connect with him there as well. Due to constraint of
Yeah.
time, we have to move on.
Nah, this is great thing actually, Pankaj. Means guys, just go to the and I believe me, those are very well explained, right? The same thing, whatever we are doing here right now. So just type your question on the
Comment
comments,
section.
and I'll make sure that I'll answer them. And when you go to my channel, it would be great if you subscribe it for the future videos also. For example, if somebody from you wants to understand SD-WAN, software-defined networking, which is the next era of networking, which we are talking about, we have a lot of videos on that. Means software-defined networking for wide area network, software-defined networking for local area network, and and so many things are there. Just try, go there, subscribe it, and just have a look at it. It has complete interview preparation series, because when I was in college, believe me, uh, I didn't have much information about networking. It took me a hell lot of time to club all the pieces together, right? But nowadays there are a lot of videos, a lot of channels available. If you really want to study, there are a lot of things, and my channel is just one of them. Okay, so if you like the way I explain things, please do go and watch those videos. Okay, it's a request. Yeah, Pankaj, do we have any other question?
They were mostly on subnetting. I think we'll drop the link. And yeah, one thing just I want to mention is, even when I was preparing for my interviews, I just searched for the networking questions frequently asked, and it was a hard time to get the pieces together. And in Vishnu's channel, we have, I think, 4-part series of interview questions. So it will be very helpful for all of you for the upcoming interviews. So do subscribe and watch those videos.
Hmm. And believe me, this kind of knowledge we expect you guys. And this is very, very simple. Networking is one of the most simplest thing I have ever see. It is quite logical. You don't need a lot of things to understand. It is quite logical, right? That's why it needs some time to understand few of the things to begin with, to complete the picture. But if you have that complete picture, believe me, this is one of the most simplest thing I have ever learned in my life, whether it's a finance, whether it's if I am reading something about health. This is the one of the most simplest thing I have ever learned. Okay, so
Yep, yep. I think
having said that, let's move to connect only two computers. And I'm taking the example of your lab. Suppose in SIT we have a computer lab, right? And in that computer lab we have two laptops, or basically two PCs, right? One PC is this one and one PC. So I'm writing down PC1, this one. I'm writing down PC2 is this one. So here, whatever the questions are with respect to address resolution protocol, why do we need MAC if we already have IP address, right? All will be answered, right? So just give me 10 to 12 more minutes, guys, whatever means of your precious time, and I will make sure that we will combine whatever we have learned together till now to make a complete solution. Believe me, if you cannot connect two computers, if you cannot communicate, if you cannot make two computers communicate, just leave the thing that you can connect the entire world. Okay, so the setup is simple. We have a switch. This switch is a layer 2 switch, right? It means that it only understands physical layer 1010 bits and MAC addresses, right? We have PC1 having IP address 192.168.1.10/24, and I will be writing this as only .10, right? If I write everything, then it is going to be wastage of your time. Then MAC address is A:(A:)A, and here we have, I will be going to write only A. Similarly, we have 192.168.1.20 and B:(B:(B), right? If you see the IP addresses of these two machines, PC1 and PC2, I can safely say that these two IP addresses are part of the same network. What is that network? The network is 192.168.1.0, right? And I am talking about two hosts which resides in this network. And what are those two hosts? One is .10, 10th host, and the second one is the .20th host. How do I know that they are part of same network? Because I can calculate the network number. This is the network which is represented by this round, right? This circle. And inside that we can have 255 hosts, right? And we are talking about communication between 10th host and 20th host. Okay. Now, before moving further, I would like to explain why we need MAC addresses if we have IP address. So consider that layered approach once again, right? We had network layer, we had data link layer, right? IP address is a concept of which is implemented in network layer. Data link MAC address is a concept where we have MAC layer. So believe me, guys, we in today's world we talk about, and by the way, we are talking about two computers which are close to each other, right? These two are part of your own lab. It means that they are pretty close to each other physically, right? Maybe within 100 meters distance, right? Maybe a 50 meters distance, right? So such kind of network which are pretty close, which are formed by this switch on and only these laptops, right? We call them as local area network or LAN. I think this is the common term which we use for a network, which is basically our local network, right? And we call it local area networking, right? Or network. So now the question is, I have IP address and I have MAC address. Why do we need this? Believe me, guys, we are talking about Ethernet in today's world, right? These green cables which you see, right? The Cat5 cables which you see, those are known as Ethernet cables, right? It means that Ethernet is one of the medium to send our packets from here to here, or 1010, okay, right? Now, if you consider this data link, it means that I can say one mode of transmission at data link is Ethernet. But believe me, there were several mode of transmission. We had frame relay at layer 2. Basically, this is layer 2. We had so many different things, right? We have ATM, so many technologies. We have IPX technology. Although the winner was Ethernet, not in terms of basically leave the wide area, but there were Apple Talk, IPX. There are so many technologies previously, right? But the winner at the layer 2 was Ethernet, and the layer 3 is IP. So you consider, if I send a packet to a layer behind it, which doesn't understand IP at all, right? Then there is a problem in identifying the devices, right? Suppose we have network layer, and before this network layer, we have a network which is based on a protocol which I do not know, right? So the IP packet will reach here in this network, and it will be dropped because nobody is going to understand this IP packet there, right? The devices which are connected. It means that to identify a device in this particular different network like Ethernet or like some other network type of network, right? We need another addressing scheme, right? Right now, MAC address is a de facto, right? We all know what MAC address, but believe me, that is just a medium. Inside this medium, there is a how to identify this particular device. And basically, we identify device on the basis of MAC because this guy doesn't understand IP address. But at this device itself, right, there is an IP address configured. Okay. So let's reiterate me once again. When we want to send this packet out of this Ethernet medium, right, to another host, although IP address is there, but this medium doesn't understand IP address at all, right? Because in this medium, we have only switch. So what I was explaining is this medium where I have only switch connected, right? It doesn't even understand the IP address. So if I send a IP packet, right, it will surely discard my IP packet, right? So what they have done is, so that we can implement network layers separately, they have implemented this data link separately so that we can have multiple option in this data link layer, right? We can have here Ethernet, we can have here some other medium also, token link, maybe a other medium, which doesn't, this token link even doesn't know the MAC addresses also, right? So we cannot send the MAC address packet or the frame in this, okay? So if you consider Ethernet, Then basically that is the media which understand MAC address, and that is why we need MAC address. So again reiterating, below this network layer we have multiple data medium like Ethernet, like tokening, like frame relay, right? Everybody is having different addressing scheme, like like Ethernet has MAC address, frame relay has DLCs, then token ring have some other medium. So to make that compatibility, right, we need different different addresses at layer 2 all the times, right? That is why we need MAC address and IP address. IP address to identify a particular logical address, and MAC address basically suppose if I reach here in this network, if I need to identify a particular device, then I need a MAC address to identify it, right? So having said that, it means that we need both the addresses. So now let's see what exactly happens behind the scenes when this guy wants to communicate to this guy. And suppose I have initiated a ping packet here, right? Just wait a minute, guys. Okay, so I have initiated a ping packet, suppose here. So what is the source of this IP packet? The source is going to be .10, right? This address. The destination is going to be .20, this address, right? Now, if I want to send this packet, IP packet, over this Ethernet medium, right? I need to attach the layer 2 addressing scheme, right? Because I know I am talking from A.A to B.B. So A colon A will be here as a source, right? But I do not know what is the MAC address of this host, right? I know what is the IP address because IP address is universal, right? A person can give its IP address to me and say that you can communicate me over with it. But I do not know what is the MAC address associated with your IP address. Then it means that, and believe me, if you want to send this frame over this green wire at your neck, which is coming out of your network interface card, this frame even won't go there unless you complete this frame, right? And how can you complete this frame? You can complete this frame if you know the destination MAC address. So here is the puzzle. You know your own, but you do not know your destination. The frame is incomplete, and that is why you cannot send it. And that is why you want to know in advance what is the MAC address of this guy, second guy, right? You understand my problem that we cannot send this packet over this wire unless we figure out what is the destination MAC address. So that is why what we do, this computer save this thing in its memory so that it can fill this IP address, right? Sorry, MAC address. So there is a protocol which solves this problem. What is the problem here? We know the IP address where we want to go, but we do not know the MAC address associated with it, right? And if we do not know the MAC address, I cannot send this packet out. So this is the problem. So what this ARP does, it resolves this problem. This guy eventually says who has this IP, which IP, .20, right? It creates a ARP packet and sends over here, this switch, right? And what this ARP packet contains? This ARP packet contains source MAC address of this interface, right? Or this PC, which is A colon A colon A. But where I am sending this to? I am sending this to everybody on my network. And to represent everybody, we have a broadcast MAC address F colon F colon F. And believe me, guys, this switch understands this address. So when this packet reaches here, and what it has inside this, it has inside this information that who has .10 address on, sorry, .20 address on my what is the MAC address of .20 IP address, right? This is the query it sends in this packet or frame. This guy reaches here, and suppose this switch doesn't know anything at all. Its table was empty. Once it receives the very first packet, it starts creating that table. What table? That it receives a frame on 0/1 interface, right? And what was the source IP address, source MAC address? A:/A:/A. So shall I assume that this A:/A:/A is attached to this 0/1? Very simple, right? Because the packet I am receiving here is this one, right? So this way switch builds its table, which we known as the CAM table, content addressable memory, right? Then the switch is programmed in a way that if it receives a packet for all Fs, right, it will be sending across all the attached hosts, whatever the hosts are attached. Maybe a host can be attached here. This packet will be going here also. And that is why if you have a lot of hosts in a particular network, then this ARP will be going everywhere. And it is problematic, right? Because this packet, because it is having all F, it is processed by every host. It is just taking the CPU of your network, right? So this packet will be going here. And this host is intelligent enough to know that this is a R packet because all are F, and it is asking who is .20, and this host is .20 because it knows its own IP address. So it will again generate a ARP reply message. So this was the request that, hey, I am .20 and my MAC address is I am .20 and my MAC address is B:/B, right? Very simple. So when it receives this packet here, it will say it is received on my 0/2 interface. It means that B:/B is attached here. Very simple, right? This way switch builds its CAM table also. Now this reply packet will receive by this host. This host know that the MAC address associated with B:/B, sorry, 192.168.1.20 is B:/B:/B, and we are good to go. Right? The packet is complete. The packet will be reaching here. It will be reaches to B. B will see that it is need to be sent to B:/B:/B, and it consults its CAM table 0/2, which is here, and then it is forwarded over here. This way the communication happens. So basically, there is a hell lot of things happening behind the scene when you initiate a ping from one computer to another computer. And what are those? I just explained you. Right? And right now, I have completed this board. And by the way, guys, how to computer talk in a same network, there is a specific video on my YouTube channel. You can just go and watch that. That is, again, explained in very layman terms, very easy way. The last thing which I wanted to let you know is how two computers talk when they are pretty different, right? Suppose you want to connect now your SIT lab with IIT lab, right? So suppose this part of the network is your own SIT network, right? You have created your own what we can say local area network. Similarly, some IIT has created their own local area network, right? And now what you want is you want to connect these two networks, right? And that is where basically we need a device which can understand layer 3, right? Because the IP packet will be going on. So this device is the router which is having two different interfaces in two different network, right? Two different total network. But if you consider the switch, its two interfaces are part of the same network, right? In same network, we need to use switch. But if we want to talk between two different networks, so if there is another host which is part of this network, we do not need this router at all, right? But if we want to talk between this guy and this guy, we need to have the router in between. And how this communication happens, guys, please do see my video, how computers talk when they are into different networks. It is explained there, very well explained there. Now, the time for your questions. Questions, Pankaj?
Yep. We have a question here. It says, can ARP protocol be compared to handshaking strategies?
No, not at all. Here, basically, handshaking means that you are initiating a session between second party. For example, generally what happens when you have a TCP connection, right? You say, hello, you there? And that guy replies, yes, I am here. Right now, there is a problem. ARP is solving a problem here. What ARP is doing, I do not know the MAC address of the second party, second host, or second computer. That is why ARP say, who has 192.168.1.20? It simply asks this, right? Who has means what is the MAC address associated with 1.20, right? So it is solving a problem, right? That to send this packet, they need an MAC address. It is just simply, it is not a handshaking protocol at all, right?
Okay.
But yes, it is a way. It is a way to check that whether the other host is there or not. So means this question is good. Maybe I am wrong. Maybe my understanding is not there. It can come across handshaking, because this way we are pretty sure that if our reply is not there, then this host is not there, right? So we are pretty sure that. But yes, there is no channel forms between PC1 and PC2. Okay.
Perfect.
Anything else?
We
Any other
have
question?
Yeah, we have one more question which says, why is MAC address always constant?
Why is MAC address always constant? Yes, because it is inbuilt into your, I think if you all aware that you have a network interface card, right? And every company who is doing this, right, who is creating this network interface card, has been given a range of addresses. So they take their ranges and just burn into your MAC addresses. Sorry, into those cards. So basically, that's why they are always fixed. So if you take a network interface card out of your PC and put it into another PC, your MAC address is going to be fixed. Okay. This because it is burnt into the physical hardware. That is why it is fixed.
Perfect. And on the same line, it's one of the question is, can MAC address be duplicated? Since it's burnt on the device, it cannot be duplicated.
Yes. Basically, you can have two different MAC address, and believe me, this video is going to explain this. So just see how do computers talk when they are in different network. It is going to be pretty very interesting for you guys. Good afternoon, wherever you are. My name is Vishnu Dutt, and I work as a network architect in Cisco.